Welcome to David Alexander Maths Tuition. This is chapter 6c, the equation of a circle. Okay, so maybe you remember some of this from GCSE. The equation of a circle is always written as x squared plus y squared equals r squared, where r is the radius of the circle. Now, if it's x squared plus y squared, then we know straight away that the centre of the circle is 0, 0. That's really important. We'll see some examples in a minute when the centre of the circle is not 0, 0. But if it's x squared plus y squared, then the centre of the circle is 0, 0. So if we have the equation of a circle as x squared plus y squared equals 8 squared, then we know straight away that the centre is 0, 0. And if it equals 8 squared, then that means the radius has got a length of 8 units. X squared plus y squared equals 36. The centre is therefore going to be 0, 0. And the radius is going to be the square root of 36, which is 6. Okay, so here we've got some examples where it's not x squared plus y squared. In the first example, it's x plus 2 squared plus y take 5 squared equals 49. Well, first of all, the radius is nice and simple. The radius is the square root of 49, which is 7. Now, what are the coordinates of the centre? Well, the centre is going to be the opposite of plus 2, so minus 2, and the opposite of negative 5, which is positive 5. So nice and easy. So whenever we've got the equation of a circle, we can get two bits of information, which is the radius and the centre. Now here, we just need to remember to flip the signs. So if we look at the next example, the centre is going to be positive 5, negative 4. So 5, negative 4. And the radius is the square root of 100, which is 10. And this final example, here we've just got an x squared. So that is going to be the coordinates of the centre is going to be 0 for the x, and for the y is going to be plus 1.3, and the radius is going to be the square root of 13, and since 13 is not a square number, I would just leave it as root 13 rather than 3 point some ugly decimal. Okay, looking at it from the other way round, write the equation of the circle. It's got a centre of 4, 7 and radius 9, so we know the equation of a circle is x squared plus y squared equals the radius squared. So therefore, what we're going to end up is the equation will equal 9 squared, in other words, 81. You can write 9 squared if you want. Now, the x coordinate is positive, so therefore it's going to be x minus 4 squared plus, in brackets, the y coordinate is also positive, so that is going to be y minus 7 squared. Easy peasy. And for this next example, the x coordinate is 0, so that will simply result in an x squared plus the y coordinate is positive, so that's going to be y take away 9 squared equals the radius squared, which is just 13 squared. We can work that out. I believe 13 squared is 169. So two ways we could write it, 13 squared or 169. Okay, so here we just need to prove that the circle with equation x plus 3 squared plus y minus 2 squared equals 125 passes through the point 7, negative 3. Well, we know that x is 7 and y is negative 3. So what happens if I add 3? Let's substitute in the x and the y value. So what happens if I stick in the 7? Well, I get 7 plus 3, which is 10. 10 squared is 100. Plus y is negative 3. So negative 3 minus 2 is minus 5. And minus 5 squared is 25. And we can see that by substituting in the x values and the y values, we're getting 125, which shows that this is a point on the circle with this equation. Okay, let's look at another example. The point 32 lies on the circle with the centre 5, negative 4. Find the equation of the circle. Well, first of all, we know the coordinates of the centre. So that's going to be x minus 5 squared plus y plus 4 squared equals the radius squared. Okay, now we know that this point is lies on this circle, so let's substitute in 3 and 2. So 3 minus 5 is negative 2 squared plus 2 plus 4, which is 6 squared equals the radius squared. So minus 2 squared is 4 plus 36, so therefore r squared is 40. Now some people get a bit confused here. Remember, the equation of a circle is some stuff equaling the radius squared. Here the radius squared is 40, so therefore it's simply x minus 5 squared plus y plus 4 squared equals 40. We don't need to work out what the radius is. Some people might feel the need for some reason to square root this, but no, the equation of the circle needs the radius squared at the end. Here the radius is root 40, which can be simplified of course, but in the equation we need the radius squared, so 40 not root 40. Find the centre and radius of the circle with the following equation. So this one's a bit different because we've got an x squared plus 6x. So what we're going to do here is we are going to complete the square on the x squared plus 6x and also on the y squared plus 5y. So let's complete the square on the x bit first. That's going to be x plus 3 all squared, take away 9. Now I'm going to complete the square on the y squared plus 5y, so that's going to be y plus 5 over 2 all squared minus 25 over 4 minus 32 equals 0. Okay, so what we can see now that it's starting to look a little bit like the equation of a circle. I've got an x plus something squared and I've got a y plus something squared, and if I just move the minus 9, the minus 24 and the minus 32 over to the other side, then that will be my radius squared. So what I can say is that x plus 3 squared plus y plus 5 over 2 squared equals positive 9 plus 25 over 4 plus 32. So therefore x plus 3 squared plus y plus 5 over 2 squared equals 9 plus 25 over 4 plus 32 is 189 over 4. Okay, so now I've got it in the form of the equation of a circle, so we can work out that the centre is going to be negative 3, negative 5 over 2, and the radius is going to be the square root of 189 over 4. It's on my calculator, so the radius is 3 root 21 over 2, and A-level maths do expect some fairly unusual looking radius lengths. We'll keep it in exact form rather than giving it as a horrible decimal, which is, I don't know, 6.8738. Much more, well, we'll keep it in exact form, 3 root 21 over 2.